Okay, these are the 14th and 16th questions in 3.4. They're the ones we didn't have to do for homework, but we're going to go over them anyway, just in case you want to know how to do them. So the first question says, what are the lengths of B and C in the particular drawing over here? Write your answer to the nearest tenth of a meter. So the first thing we have to do is we have to see that what I'm drawing right here is a right triangle. If I bring it down and put this in here, we don't know this length. We do know this length, and we do know this length. So what we have here is we have a right triangle where we know two of the side lengths and not one of them. So what we actually don't know is one of the legs. So if I draw my squares on here, and inside there write my areas, this would be an area of 25, the hypotenuse square. This would be a 9, and what plus 9 is 25? The answer would be 16. And since the area of that square is 16 meters squared, then the side length must be equal to 5 meters. Okay? So the first step is to find B. And once you know B, then you'll be able to find C. So then what I'm going to do is I'm going to take this triangle here, I'm going to draw it, I'm going to bring it down over here. Okay? So we already know that B is 4 meters. And if you look down here, this base is really 2 threes, which makes it 6 meters. And C is going to be the hypotenuse. So this time I'm going to use my formula. So I'm going to use a squared plus b squared equals c squared. My a is 4, so 4 squared, plus my b, which is 6 squared, equals x squared. I don't know it. So 16 plus 36 equals x squared. That's going to be 46. That's going to be 52 equals x squared. And to isolate it, I'm going to use the square root of both sides. Square root of x squared is x, and the square root of 52 is probably like 7.2 or 3. Take my calculator out and go the square root of 52. It's 7.2. So approximately 7.2 meters is the answer for B. Okay, so back to here. Your B is 5 meters, and your C is roughly 7.2 meters. In question 16, what is the length of the red diagonal in the box? So we have a box here, and it's a really tricky question to show how to get the answer. But what I'm going to do is I'm going to pretend that we're looking straight down on that box. Okay? So if we're looking straight down on that box, this distance here would be 12 millimeters, and this distance here would be 7 millimeters. Okay, mm. So that would be 7 millimeters. This actual 5 millimeters is right here. That's the height of the box, and I would not see that looking straight down. So the first thing I'm going to do is I'm going to actually look for the distance, the diagonal distance across that top there. So really, if I think about that diagonal distance, I'm really thinking about a right triangle, and I really don't know. The diagonal is really just the hypotenuse. So if you look for the hypotenuse, we have areas here. So we'll put a 144 in here and a 49 in here. And the area of the square attached to the hypotenuse will be the sum of those two, which is 193. So the square root of 193 is really the distance. If we take 193, oops, there's my calculator's gone. Take 193 and press the square root button. It's 13.9 roughly. Roughly 13.9 meters. That's the first step. But really, we're asking for the distance from this corner to the top corner of the other side. So now what we want to do is we want to think about the side view. If I was to cut into that, so if I was to cut it from diagonal to diagonal, I would have a 5 millimeter high, and you have to think about cutting it. You know, if I was looking for from the top, here's the top. I'm going to cut it this way, and I'm actually going to hold up this side here. And if I look at it, it would actually be a long rectangle. It would be 5 millimeters high. It'd be 5 millimeters high. And the diagonal, which we just measured, would be actually this distance right here, which is 13.9. So from the bottom corner to the top corner is going to be really the hypotenuse of a new rectangle with 5 and 13.9 as distances. So we put our squares on there. This would be 25. And the area of that square would be 25. The area of the other square would be 13.9 squared. which would be 193.21. So the area 193.21 is the area of that square. And the area of this square, I can erase this stuff, the superfluous stuff, is actually 193.21, 193.21, plus the area of the other square, which is 25. And that's 218. So the area of this square would be 218.21. And the square root of that number would actually be the distance from corner to corner, which is roughly 14.8 millimeters. Now I know that's really complex to kind of show on paper, but if you come into class, I'll show you with a three-dimensional object to make sure you can see it a lot better with that. But the answer to the question is, from the bottom corner to the top corner, across through the middle, is 14.8 millimeters.